All right, so there's only two rules. First of all, if light travels parallel, we all know what parallel is, right? This is parallel to the principal axis. I've already drawn the principal axis. If it's parallel, when it hits a reflective surface, right? So light is coming straight in, okay? If it hits a curved mirror, right? It's going to, actually it doesn't have to be a curved mirror, but if it hits a curved mirror, it's going to go through the focal point. Okay, so this is the incident line because it's going into the mirror. This is the reflected arrow, reflected light wave going through the focal point. Okay, now how do you find where an object is? Well, you have to have two reflected waves, and wherever those reflected waves intersect is where the image is. So I'm going to go ahead and draw an object. Since I started here, you always start from the top of the object. The bottom of the object, if it's on the principal axis, will always stay on the principal axis, okay? Which is why you want to start from the top of the object. Doesn't matter what it is, stick figure, arrow, star, whatever. So we've done an incident wave. We've gone parallel through the focal point. That's rule number one. Rule number two is if you go through the focal point. So we're going from the same place because we want to know where his head is. The top of his head is going to be wherever these two reflected waves intersect. Not where the two incident waves intersect, not where the incident intersects the reflected, because they're going to intersect at the focal point because we're going through the focal point. And by the way, you should be using a ruler because most of you are probably worse at drawing crooked lines than I am as far as straight lines go, right? So we went through the focal point. When it hits the mirror, it's going to go through the focal point, and when it hits the mirror, it's going to bounce parallel. So again, parallel to the principal axis. So we draw it straight, right? Again, get a ruler, don't do like Mr. Weiss. And we notice that this is where the top of his head is. Okay? So, and again, he doesn't look like down here. If his bottom is on the principal axis, his bottom is always going to be on the principal axis. And so, there's our image. Okay? That's for, what type of mirror is this? It's curving around us. This is concave. Okay? If we did convex, the rules don't change. Right? The only difference with the convex is the object is on the principal axis over here. This is you looking in the mirror, right? And you're looking in this big concave mirror. The only difference is the focal point is inside the mirror, right? This is a real image. This is real light coming outside. Nothing's really inside of a mirror. It's just an optical illusion. Okay, but where would your reflection be in here? All right, and again, there's only two rules. Doesn't matter what type of mirror it is. If you are parallel, you go through the focal point. So we're going to draw our incident going parallel. Now, light's not really going to go through the mirror, right? It's actually going to reflect off the mirror, but it's going to look like it came through the focal point. Right? This is why it's an optical illusion. Where it really came from is here, but your eye is going to tell you it came from this point of origin, right? The focal point. But notice I followed my first rule. Parallel through the focal point, right? What's the second rule? If you go through the focal point with the incident ray, reflected ray or wave is going to bounce parallel. So now I'm going to go with my incident wave. I'm going to make it look like it's going to the focal point. Okay, and again, you should use a ruler. Okay, so that line is going to pass through the focal point, but it stops obviously when it hits the mirror. And when it hits the mirror, because it looked like it was going through the focal point, it has to bounce parallel. So this is going to bounce parallel. Now you notice these two reflected waves, these are the reflected waves, and I said the image is where the reflected waves cross. They never cross out here, right? Not in reality. So this is not a real image. This is a real image because the light waves really bounced off the mirror and intersected right here. That's a real image. This is real. Okay? They're never crossing over here, so this is not real. But what they do, and this is what your brain does, this is why you can see your reflection in a mirror. Your brain says, well, I understand that this is where the light's coming from, but where does it look like it's coming from? And your brain backs it up and says it looks like it's coming from right there. And again, we started from the top of the head, so there's the top of the head. Okay? If the feet are on the axis, the feet are always going to be on the axis. Right? So there you go. When you look into a convex mirror, you see a smaller upright image, and this is not real, right? There's no real light back inside the mirror. That's called virtual. All right, when you look in a concave mirror, you get a real image that's inverted, and notice this is upside down, and it's practically the same spot because we actually ended up putting the guy on the center of curvature, which is 2 times the distance from the mirror to the focal point, right? If you looked in the PowerPoint and saw, you know, the different points, the principal axis, right? The focal point in the center of curvature, which is 2f. All right, that's mirrors, okay? We'll get into lenses in the next video.